clean. So we upsample it a little bit, but we make sure too extremely. We just have to do trial and error. Once we have a taxonomy, we have to do some different training runs and experiment with different sampling ratio. Yeah.
Sebastian, the temperature-based sampling, if I understand it correctly, you mean that for the training, right?
Yes, during the training. Yeah. Yes.
So that would mean even if we have like a huge disproportionate amount of certain category, we take fewer of those so that it doesn't hurt the other categories?
Maybe not really taking fewer of those, but what we will do is we will just take more of the little ones. So if the small category has only 20,000, then maybe we copy it 5 times, so we have 100,000. So in that sense, we are not throwing away the good data where we have too much, but we just make sure that the model has seen enough of the small domain. Yeah.
Okay. Kande, can you talk about the next one, the synthetic data option?
One second.
Okay.
How much on the same topic? You said like 1,000 sentences for the benchmark for one given subject. Do you have like any range of sentences, number of sentences?
For the total size of the evaluation.
No, for the total 1,000. So just like 10 sentences per. No, 100 sentences per genre topic, or?
I think that's too little. I would say at least 1,000 sentences per genre. Because
okay.
Sebstain, can you say in terms of percentage? Like it's a little bit confusing if you say like.
No, it shouldn't be percentage because everything has to be balanced.
Yeah, it should be balanced, but like.
If you put percentage, then it's not going to be balanced.
No.
Because we have a lot more Buddhism than biochemistry.
Mm-hmm. I get it.
Yeah. Okay.
What I'm trying to say is like the total number of sentences that we are preparing for the benchmark dataset. What should be the percentage of like total number of? What should be the percentage of that number if we compare to the whole training dataset? Like let's say we have like 1 million training sentence pair. Like what should be the percentage, like what should be the benchmark, then we can distribute or according to.
So my opinion, and maybe some other people will disagree, but you have all these rules in machine learning, how to train a model where you say 90% is trained, 10% is for testing and evaluation. But I think this is kind of that comes from the time when we trained CNN models on like 50,000 samples. It's like, okay, it takes 2 hours to train the model, so it takes 15 minutes to evaluate the model. Okay, let's take 10% split. If we take 10% of our data set, then we have 200,000 evaluation sentence pairs. It will take actually 8 to 10 hours to evaluate the model, and that's just ridiculously slow. So I think we should really just take a fixed number. Like even 10,000 sentences means that the evaluation takes 1 hour, and 1 hour of evaluation time. It's doable, but it will just slow the training down so much that we can only evaluate like every 10 or 20 hours because we don't want to lose 50% of our training time for evaluation. Yeah, that's not nice because the decoding step is so slow. So I would just say, I mean, we can check. Let me check how big the Flores is for each language. But I think Flores actually for each language they have 5,000 sentences if I'm not mistaken. Like the multilingual benchmark for all 200 languages. I think they take 5,000 for each language, if I remember correctly. So if we have 10,000 for our data set, like 10,000 would be the sweet spot, I think, because that's certainly big enough to have a good coverage of the different domains, but it's not like we have to wait the half of the day for the evaluation to finish. So that's my opinion, but maybe somebody will disagree, I don't know.
It's 10K total, not 1K to
10K, yeah.
10K. 1K
1K each. 1K from each category.
1K each?
If we have 10 category.
10K total. Yeah.
Okay. Yeah.
If we have 10 category, that's the assumption.
Okay. Yeah, I think this is enough. 1,000 sentences per category, and we want it to be of good quality rather than having too much quantity.
Yeah.
I got it.
Okay, let's move on to the next one. Synthetic data options. What did you mean by that?
Yeah, what I mean is like I've been hearing that you're a little bit skeptic about synthetic data, I want to get, I want to understand more like why you're skeptic about synthetic data, because like I've seen many of machine learning model using synthetic data and using and data augmentation approaches to train the model. So yeah.
So I think two things on this one. And so first of all, we need to check if there's a paper that proposes any like synthetic augmentation strategy. We really need to check if the paper is actually using a pre-trained language model or if they are training a transformer from scratch. Because if we train from scratch with randomly initialized weights, then any kind of synthetic method is very effective because we don't have any bias in the model. But if we have a model that is already pre-trained on English, maybe even Tibetan, then the model actually, the synthetic data might lead to catastrophic forgetting. So the model actually forgets pre-trained weights. So a lot of synthetic approaches are only really efficient if the model is trained from scratch. But so I think there are certain approaches that might work for us. So in my very recent experiments, I think back translation is actually slowly starting to really show good results. And especially we have this, I think you already have it noted on the next point, but we have this problem of dropping of sentences. And back translation seems to be really efficient to challenge that. So let's say the glass is half full. We really have to check out what we mean by synthetic data. And I think especially to increase the coverage of our target domain, back translation can be great. For example, you have all the news articles, and we can actually just take English newspapers and back translate them to Tibetan, and that will at least increase our coverage on that end. So that actually can be really helpful. I think back translation is something my opinion has improved. For other synthetic approaches, we have to evaluate and just look precisely what the strategy is, and then we can see if it works. Yeah.
Can you elaborate a little bit on what do you mean by back translation? I'm sorry.
So back translation, for example, we have a big corpus in our target domain. So we want to translate Tibetan to English, and we have a large corpus of the English material, but we don't have so much Tibetan on that material. So we first train a machine translation model that can translate English to Tibetan. So it does the backward direction. And then we take that model and translate the English corpus into Tibetan, and then we use that data as well to train the model together with our original training data. So we have fake Tibetan as the input, but we have the original English at the output. So in that way, the model will learn to produce higher quality of English output. And it also works the other way around. So when we have a large Tibetan corpus, but we don't have that much English data, then we can first train the model to translate the Tibetan to English, and then we use the fake English to generate the Tibetan. And in that way, we can use more data in the training. So it helps with fluency, but it doesn't really. So so far my experiments are, so this really helps with the dropping of sentences, and it also gives more fluency to the model, but it necessarily create new abilities. So if the model is bad at whatever news translation or so on, it's not like a miracle solution. It's not like suddenly, okay, this is working great, but it gives some improvements to the model behavior. Yeah.
Sachin, if we have a huge amount of English data and not as much Tibetan, then how do we train the model in the first place? Because we need pairs of sentences, right?
Yes. Yeah. So we have to use the data that we have, whatever we have, and we train the model from English to Tibetan on the data that is available to us. And then once we have that model, we can translate all the English into fake Tibetan. And
okay. Now I understand.
Yeah.
Okay.
It's kind of limited. That's the problem with back translation is because I think especially for our news domain in Tibetan, because we don't have so many news articles translated into Tibetan, and that's kind of the bottleneck. Yeah, it's not like we have millions of news articles in Tibetan and we just need to back translate them, but it's more like that's really limited, and even if we try to increase, it's probably not going to make such a big difference. Yeah.
Okay, so this one gathered some attention. Lost sentences at end of every paragraph. Can you go over, please?
Yeah, so when we run inferences on like a paragraph or like a bunch of like a collection of sentence, uh, what happens is like it kind of skip the last sentence, or
Yeah.
yeah, so we are having that issue. uh,
Mm.
yeah, so what are your thoughts on this case?
So I think I'm since about 2 weeks I'm working. I'm training a new model, and we had to change the data composition and so on because we also have loss of sentence problem in Tibetan to English translation. So that happens in both ends, and I think like Kurt is very annoyed by that, and for that reason, the new model will hopefully just solve this because we have changed some ways on the data composition, and the inference pipeline is also different. So and let's hope that this new model will just solve it. And if we still see the problem, then we have to look closer at the data. But to be honest, like right now in the model, in order to make like multi-sentence translation possible, I had to do a bit of hacking on the inference pipeline, and the code is not very nice. So actually, I used some very simple heuristic to chop the input into multiple sentences, and then these multiple sentences are fed to the translator. But this method is like it's a bit buggy because in order to decide where you break into sentences, it's not that
Clear.
straightforward. It actually happens sometimes that the chopping of the sentences is not really in line with the way the model digests the sentences. And I have some suspicions that we get this problem because this chopping is not optimal. And that's, I think, one of the reasons why we see so much sentences getting lost is like that's just suboptimal. And in the new model, I won't do that at all. So we will just feed it directly because that also uses a different inference pipeline. It's called TGI, and I will make you a GitHub repository. So also, if you guys want to run your own inference, it's actually much easier.
Yep.
And all the code is written and hosted by Hugging Face. So it's not like just me hacking something together, but it's some code base that is actually really approved by many other people. So I really hope that if we move to TGI and use the new model, that will disappear. But let's see.
Okay.
Sebastian, the new model has a newer data composition, training data composition, as well as using a new inference pipeline.
So the training data composition is, so the base data is still the same that I used for the last model. So I'm of course waiting for the, if you guys have new data, I'm super happy to include that. But it's still the same data from October. But we use monolingual data together with sentence pairs. So that model actually has a 50-50 mixture. So 50% of the data is Tibetan and English, and the other is the sentence pairs. So that's I think the English will not change much, but what I hope with this model is that the Tibetan will actually be much better because it has seen the Tibetan corpus during pre-training. So we will see how good the quality is, but once the training has finished, I will just upload it and then we can test it. Yeah.
That's a new model. That's not no language left behind. It's a new
Yes, it's a different one. Let me. So the paper, if you want to read it, it's called MATLAB 400, and the paper is by Google DeepMind. So if you just search that on archive, you should find it. I think their results are not much better than No Language Left Behind on high resource language, but they have a better training paradigm. So if you read the paper, I think it becomes obvious that this is like more suited for what we want to do.
Okay, is that the reason why we need 50-50 percentage of monolingual and the kind of data we had already aligned?
Yes.
Because that model takes it. Okay.
Yeah. And another advantage is that this MATLAB we can actually train in multiple directions at the same time. Of course, we can do that with no language left behind, but that actually makes inference very complicated because we need to submit this special forced BOS token for each of the sentences. Is actually not that nice. And this MATLAB, actually, I'm actually training Tibetan to English, English to Tibetan in the same model. So we only have to host one model. That makes our life much easier. And also, Tibetan, tiny Chinese Tibetan is also difficult. just cover everything with one model.
Okay,
So
so
sorry, the Japanese, you were demoing on Twitter. Is it
Yes.
with MATLAB?
Yes, it's also included. Yeah.
It's also included. Okay. So basically, we'll be able to just add the tag and also translate to other
Yes.
language pairs with that.
Yes. With MATLAB, we only have to supply a tag to indicate the target direction. So we just say like to Japanese, and then it will translate whatever input it gets to Japanese. So
Right.
English.
How many languages? Or it's probably in the paper.
Yes, so they cover like 400 languages, but of course, once we start to fine-tune our data set, it will slowly lose the ability in the other languages. So, like if we have Tibetan to other languages, like whatever Russian, French, and so on, even if it's only like 10,000 sentences or so, if we can include that in the training process, it's actually great because it prevents the catastrophic forgetting. It will just be like an anchor to make sure that the model just keeps the knowledge. Because I only had 5,000 Chinese to Japanese sentence pairs, so that's like nothing, yeah? But I added that to the training, and it was actually enough to get the model able to translate Tibetan to Japanese. So it was really cool.
Yeah, I tried to, Tibetan to French. It works quite well. But it forgot Hindi. So I guess it's because of the centric data. Is that right?
Yeah. So you tried it on the Dharma Mitra website.
Yeah.
Okay. Yeah. Okay. Yeah. So yeah, for Hindi, precisely. We just need a small set of sentences, just 10,000, 5,000, and then it will stay in place. Because I think if we don't have any signal, it will just the vectors will just float away. But if there's a bit of signal, then they will stay in place, I think.
Okay, great. So maybe we'll try to at least cover all the traditionally Buddhist languages.
Yes.
Yeah, like Vietnamese and Korean and whatever. Yeah.
Yeah, that would be great. Yeah.
Okay. Okay, great.
Before earlier with no language left behind, it's a two different model for the two directions, English to Tibetan and Tibetan English.
Yes.
Totally two different model. Does it not handle both the direction at the same time?
No, the no language left behind didn't do that, and I think that's the reason for that is because if you train it in the Hugging Face library, you actually have to kind of hack the BOS token into each sample. It's doable, but it means to actually do a lot of like additional programming, and I was always feeling a little bit too like I had lots of other things to do, and I just never found the time to do that. And actually, the MATLAB is much nicer because we only have to supply the target token. We don't need to worry about EOS and BOS tokens, so it's just much simpler training paradigm, much nicer to work with.
Yeah, Sebstain. So you said earlier you used to break the sentences, break the paragraph into sentences manually, like with the script. Why did you break it into sentences?
Just to understand again, so
there was this problem of lost sentences at the end of every paragraph, right? And then
Mm-hmm. So I think that the main reason is that I did that because if you take like 10 sentences of Tibetan and you click on translate, or 10 sentences of English, you click on translate. In the older version of the inference, you had to wait like 20 seconds for your result to come, and then maybe the user will already be frustrated and just go away and say, okay, this stupid website is not working, I don't like it. So the idea was to just take the first two sentences and translate them quickly so the user gets a feedback, and then we take the next two and the user gets another feedback. But I think the thing is that TGI will just handle the token streaming very nicely, so it's actually very efficient on that end, so we don't need to do that sentence checking anymore. We can just do it right away.
Yeah, that brings us to the next point very nicely, because the problem we had with the existing machine translation UI at the magam.ai website was that we were sending each sentences separately. Every time there's a line break, we do one API hit and do one translation.
Okay.
Then we get the results back and then we display it. So that takes care of the time taken for inference issue. But one issue we thought that would create is that it would lose all the context that's in the structure of a paragraph and also structure of poems and verses. So with the new model, would it be better to do one API hit per user input for the whole?
So I think with the new model, what we can do is, because, for example, if the user gives 4 sentences, we can just pass the four sentences as one paragraph to the API, and then we will get our return token. The only thing that is a bit tricky is because the model is trained on 256 token context window lengths, and we need to somehow guess when we reach that. So it's kind of, we need to give a limit for the user, because if the user inputs 2,000 characters or like 50 sentences and they click on translate, then only the first 5 sentences or the first 10 sentences are translated, and then it just stops. And so we need to guess how many inputs we allow for that not to happen. So maybe we just say, okay, 700 characters and you can't enter more, so we kind of put it in the text box that you just can't enter more than 500, but we can also batch it. So we can also say, okay, we have 1,000 characters in, so we cut it into packs of 500, and then we do one after the other. That might also be possible. So we need to see how it can work with it.
Okay, yeah, so the tokenization step doesn't take that much time, right? So if we run the tokenization step and see if it fits in the 256 token window at the front end, then is that also a viable solution?
I think the one thing is that the tokenizers, of course, it's a Hugging Face Python library, and I don't think we can make that one in JavaScript, but I'm not entirely sure. Maybe there's some sentence piece implementation for JavaScript. That would actually be very nice. Then we can really do it directly on the front end. But we could also create an endpoint for that. Just, sentence input, and then you get the number of tokens back. I think that should be something like 5 milliseconds of round trip time. It's super fast. So that might be another way to just do it as a small backend code.
Yep.
Okay, yeah, thank you. So the next question we have is will external language model work with post correcting model inferences? Like if we have a language, this is not specific to machine translation. This is also for speech to text. If we have an external language model, is there an effective and cost-effective, way to use that language model to post-correct the output we get from other models?
So how would you create a spell checker basically with language model?
I think I have, like, at least for the translation model in the earlier testing phase, we actually used ChatGPT because we had this problem that when we translate one sentence at a time, then of course the context is not so great. So the first sentence might have a very different context with the second and so on, and the result is not coherent. So we used ChatGPT to post correct that, and it actually worked quite well. And also very early when we trained like half a year ago and we had only the smaller data set, and actually there was a lot of like omission of sentences and also repetition of the same word 10 times and so on that really looked terrible. And actually ChatGPT is very good at filtering that out. So it was quite efficient to brush up the result and not to make all those problems visible to the users. But yeah, of course for the release we have removed that because it's too expensive. But of course I think it's a great way to improve the output.
I guess one of the main questions for Tibetan. The Tibetan ChatGPT doesn't work. So we were discussing actually, using a language model, not an LLM for Tibetan because of obvious reasons. So do you have experience, basically using a BERT or T5 or whatever, to do, spell checking?
Sure. I think that should actually work quite well. I trained that for Sanskrit once because I made too many mistakes in my master's thesis, so I wanted to have a spell checker for Sanskrit, and it actually worked really well. So the only thing is you need to think about a training objective. So you need to just, maybe you can create a, so my suggestion is you create a table of the most common spell mistakes, like 100 common things, like people, whatever, like people make mistakes. So you know the language better than I do, so you certainly have a feeling of what mistakes are likely. For example, on Sanskrit, just to give you an example, very frequently you forget to have a long A, you have short A instead of a long A, and so on. So all these kind of things, they are of course very sensitive, and then you can just create a table of the most common mistakes, and then you can randomly introduce them in the Tibetan, and then you train the model on removing those mistakes. And if you have a big corpus of like many gigabytes of data, then just by the law of high numbers, it will be quite good at that. So that's my suggestion. So you can just use a random number generator to introduce it. Maybe you say, okay, every second sentence gets 5% of mistakes, and in that way the model will just learn, okay, when the sentence is clean, we will just copy it over, but when it contains mistakes, then we fix them. So I think that's actually, spell checker sounds very easy to me in Tibetan. I don't think it's going to be a big challenge. So
Ashim, what kind of model are you thinking for this task?
I would go with T5 because that's an encoder decoder full round trip model. Yeah. So my suggestion is to go for T5. Yeah.
Spell checker for Tibetan without tokenizer, do you think it's possible?
We need a tokenizer, that's for sure.
Okay.
So
tokenizer, you mean word tokenizer or just like sentence piece tokenizer?
I think sentence piece will be good enough, but one suggestion is, if you want to experiment, there's one model that is called by T5. That's actually T5, but it's trained not on word pieces, so not on sentence piece, but it's trained on the actual Unicode bytes. So that's for spell checking purpose. It's a bit nicer because it really goes each letter separately. But I think by T5 is not pre-trained on Tibetan, of course. So we need to do our own pre-training. Okay. But yeah, if you have a big data set for Tibetan, then I can pre-train that way. And then you guys can just do the fine-tuning of the spell checking task as a separate step. For that, maybe you need 100 megabytes or so. I don't think you need gigabytes of data for the spell checking. So yeah, that's my suggestion.
We have actually a lot of errors, like pre-post correction data that we can use with any spell. So I think that will be quite straightforward. Yeah.
Yeah, I hope so. Yeah.
Okay, so the objective for the model is we give it a sentence with artificially injected spelling mistakes, and then its job is to translate those into correct spelling, right?
Yeah.
So it's just like a translation model.
Yes. It's a sequence-to-sequence translation model, and we can use the same architecture also to post-correct OCR mistakes. Actually, it's the same.
Same thing.
Oh, I missed that sentence. What did you say, please?
We can use this similar approach for OCR also.
Oh, yeah. So I think you already covered this question. We were wondering why you need a monolingual text corpus. So apparently it's for this model, right? This model.
Yeah.
MATLAB.
Can you?
And I guess we should read the paper to know how it's used, or
right.
We can give a 2-minute intro.
Let me just quickly give you a link. So actually there's the MATLAB paper, but there's also another paper by the same team. So this is all Google DeepMind. Very interesting because they have described in that paper how they actually extended the Google Translate to include Sanskrit and other languages without using any sentence pairs. So they just use the monolingual data for that. It's really interesting. Yeah.
Okay, I'll add that to our reading list.
I just saw you joined us.
So the next question we have is, we are facing this problem of hallucination in Whisper because it's an encoder-decoder model, and even though we have more data, when we use data augmentation, the last training iteration we did, the hallucination was even more pronounced. So we were wondering if you have any, suggestions on how to tackle that problem.
Yeah, I think hallucination is really frustrating, and Kurt and I had lots of discussion on what caused hallucination. So I think Kurt is a bit of the opinion that hallucination must be a problem that is in the model architecture, while I disagree, and I just say hallucination is a simple result of not having enough good data.
Okay.
So it's kind of, you don't have enough good data, you get hallucination. And sometimes we add data and suddenly the model hallucinates more, which could be a hint that the data we added has problems. So we need to just look at it. And, I think for Sanskrit, I have seen that if the translation is very free, if it's like very poetic, like people add a lot of stuff or they remove a lot of stuff, then actually sometimes the adding data can be resulting in a model that is not as good as before. So, and that's really frustrating. And I know the way to fix that is very complicated. So, not really complicated, but takes a lot of time. So you have to take your original data set, then you add just a little bit of the new, you see what happens, you add a little bit more, you see what happens. So you go like one step at a time. And then eventually you will see where the problem is. But yeah, I think there's no easy solution to that. And hallucination is just, it's a real problem. And we have it all the time, yeah.
Okay.
Yeah, that's what I noticed. Adding more data doesn't necessarily mean the CR would go down.
Yes. So yeah, I think my suggestion, so if you see that you add new data, but the quality actually goes down, then really do a grid search on the data. So you can maybe divide it into 10 buckets, and then you just add the first, add the second, add the third, and then eventually you will hopefully see, okay, when we add the number 5, that actually the quality goes down. And that's maybe the most systematic way to check that. Yeah.
Okay, gotcha. So it's
pretty expensive.
Yeah. That would take a lot of iteration on the training run, right?
Right.
Yeah, it's painful. It takes a lot of time. Yeah.
Okay. Next question is kind of important. That's from Desiree. So you were wondering the viability of using BERT for word segmentation, NER, part of speech. Is it a good idea to train BERT from Tibetan corpus and then use that for all these downstream applications? Or is there a better approach?
I think just so we don't have to train so many different models, just to save us some time, I think we can train a T5 model, and then because T5 actually can also cover those downstream tasks like name entity recognition, word segmentation, and so on. So just to save us some time, I would say we just go for a big T5 model and use that for all our purposes. That also means that we don't have to have so much different code and adapt everything to different models. So that's my suggestion here. We can train T5 for that. Yeah.
And we don't need to fine tune it for different tasks, or?
Oh yes, we have to do that. So I think we first have to pre-train it on the biggest corpus we have, and then we can take that, fine tune it on spell correcting, on OCR correcting, on named entity recognition, on word segmentation. We just need to have good data sets for each of that, of course. But we can then fine tune the model on the different tasks and have specific models for each task. Yeah.
Oh, okay.
I'm confused a little bit. So BERT is just an encoder model, right? And T5 is a sequence, but for token classification tasks like NER and POS and word segmentation, it's a problem of classifying each token separately, right? And how does that work when you use a sequence model rather than an encoder only?
You just need to be a bit creative on the way how you formulate your output sequence. So, for example, if you train the encoder-decoder model on word segmentation, then in the output you just put the entire sequence of the input again, but you introduce some token after each word to indicate the segmentation. So in that way you just have to think like a translation task. And the same goes for named entity. You just in the output just look at the word that you want to recognize, and then you add something to mark. Yeah.
So the only thing we need is translation. All we need is translation. Yeah.
Translation is all we need.
Translation is all we need, yeah.
Yeah, now I understand. Okay. So the input is like a sequence of tokens, and in the output, wherever there is a word segment, boundary of a word segment, we artificially add a special token to denote that, and then that's like a translation task. Right?
Yes. And for example, if we do part of speech tagging, so you have your input, which is your Tibetan sequence, and then the output, for example, you can only give it the part of speech text separated by a space or whatever. So in that way, the model will just learn to predict the part of speech text. So yeah, I think it just requires a bit of creativity to model the thing in a sequence-to-sequence task. But T5 generally, I think, is a bit more efficient than BERT when it comes to the training paradigm. So it's kind of, because we have a decoder, so the model is a bit deeper. The only drawback is that the decoding is slower. So if we want to have it in a very fast context, so if speed is really important, then BERT ultimately is a bit better. But if it's more about speed doesn't matter so much, we want to have high quality and we want to have an easy time while we program and so on, then T5 is better because the sequence-to-sequence is just nicer to debug and nicer to work with, I think.
Sebastian, how is it easier to debug?
It's easier because you can see the result. And that is like you can actually look at the sequences it generates and then you understand where the problem is. And if you only get logits for each, then it's a bit more, well, it's okay. I don't think the difference is so huge, but it's kind of, I think the decoder makes it a bit easier to observe the model behavior.
Yeah. Okay. Yeah, so we have come to the last question. For the ternary loss that you're using for sentence transformer, it takes 3 examples, right? 2 of the same meaning, but the third one should be of a different sentence, right? Is it actually a random sentence that you pick out of the corpus, or do you pick one that's really similar but not exactly the same meaning? Because that was one alternative one of our colleagues was mentioning.
Yeah. So you mean for the sentence similarity for the
Yes.
alliance?
Yes.
Yep. So actually, I experimented with both. So there are different. There's this library called sentence transformers, and they have all these different the different loss functions are explained there. So I think the one that worked best for our purpose was the multiple negative ranking loss. And I think that's basically how it works, is that there's one positive example and then it samples 10 different negative examples, and that's included in one batch. So for each positive, there's like 10 negatives. And actually, I think it really works quite well. And of course, what we can do is we can try to hand the negative examples, but that I didn't do. So I'm just randomly sampling the negatives from the whole corpus. But of course, it's possible to use something like KNN retrieval to sample them. But the question is, do we have a good intuition on what negatives we want to use? If we have a good idea what kind of things we want to avoid, then it makes sense. But if we don't have a good idea what we want to avoid, then it also doesn't make sense. So, and my feeling is that for the sentence alignment task, it's not, like I don't have a clear picture of what we want to avoid. For other tasks, maybe we have that. So I think it really depends on how we understand the data. Then, yeah.
Yeah, one question, DJ, can you take over that question? The 0.8 rating, how did you come up with that?
Oh yeah, I saw something like a label for like how similar the sentence is. It's like 0.8 for like the ones were. So do you label it or like or do you use another approach?
Yeah, so I think there are different. The different loss functions have different objectives, and the one that I'm using just optimizes for. So there's no label involved. There's just a positive label for similar and a negative label for dissimilar, and in this way the cosine distance is like pushed in the right direction. But if we have like finer graded annotated data, so we have something like fully similar 1, and then we have like pretty similar but not really similar 0.7, and maybe not so similar 0.2. So there are such data sets exist for English for high resource languages, we have that, like really semantically annotated sentence pairs. But we don't have that for our data sets. I think we really have the sentence pairs, and in that way, yeah, that's something we cannot do. Yeah.
Okay, so all the labels come from the annotators, right? When they make an alignment, and if it's actually aligned, you just give it the score 0.8. That's something the sentence transformer library expects. Okay.
Yes. Yes. Yes.
Okay. Okay, so that's 1 hour for us. Thank you for spending your time with us.
Yeah.
That's
No
all the
problem.
questions
No
I've got
problem.
now.
Yeah, I have a one more question.
Sure.
So,
Sure.
We
yeah,
have
we're
only 3
looking
minutes
into
left. Kamasam Hazdalega.
Okay. I have 3 minutes. Okay, so basically, yeah, we're looking into hold on. We're looking into translation from Tibetan to Tibetan with different I mean graded text. For example, Tibetan for 8 years old, Tibetan for 5 years old, and this kind of stuff.
Yeah.
So I guess it's also a translation problem.
Yep. Sure.
And so how much data do you think would be needed to cover one genre, one topic, let's say like stories?
Much less than you might think. So when for example, I got this from Kiyonori in Tokyo. I got these 5,000 sentence pairs from classical Chinese to Japanese. And basically, the Japanese is more like an annotation of the Chinese. It's not really a translation in the sense that they use new words all the time, but it's more about, rearrange the grammar structure and so on. And these 5,000 sentences are actually enough to train a model that is pretty good. It's like not perfect, but it's really, really good. And it's actually quite usable. And I think, when translating Tibetan for 8-year-olds, I would also guess that's more like a simplification of language. And probably
right.
you will stick to a lot of the same words, but maybe grammar and so on, it's going to be more simple. So I think if you get like 10,000 sentence pairs, it will be pretty good. So you don't need to have 100,000 or so. Just 5,000, 10,000 will get us quite far, I think.
Okay, great. Yeah, that's good to know. But does it imply that actually the model needs some material that is written for 8 years old, in the monolingual corpus or something at the beginning, or?
Not so much, I think.
Okay.
That's going to be fine. We can also use the T5 model to fine tune it on that. So, yeah.
Okay, great. That's very good to know. Yeah.
Kishimadam, do you have a question? You were raising your hand. You are muted right now. Can I mute Risha?
Okay, Sebastian, I'm waiting for you the local animation translation.
Yeah.
How is this?
Yeah, so the new model, I just talked about this. I think it was maybe shortly before you joined. I don't remember, but the new model that I'm training at the moment, you can also run it locally with TGI. So TGI is very comfortable. Actually, there's a Docker image for TGI, and in order to run it locally, it's only one comment. And I will create a GitHub repository for this, hopefully today or tomorrow, and then you can just run it locally on your machine. So that's yeah.
Yeah, thank you.
Yes.
Yeah.
Tomorrow is fine. It's Christmas.
Yeah.
Sebastian, I had a question. I
Sure.
think Sonopins have missed it. I was thinking about since we have already aligned data of English and Tibetan pairs. So for NER, I was thinking if we could create kind of algorithm that transfers annotation, projects the text. So I was thinking about using your BERT for your use that you use for sentence transformer, and kind of pulling the n-gram tokens and just trying to see so what do you think about it? Will it work or
I think it's an interesting idea, and I always wanted to try this, but I never had time to do it. But I think it should be actually very interesting to compare and maybe to also generate some embedding for each of the tokens, and then to try to match the highest. Basically, there's this Hungarian algorithm that tries to create the shortest path between when you have two sets of entities. So I think there's like various ways to do that, but I would be super interested if you want to try that out. What kind of experience you get with that? So for my feeling, that sounds very promising. Yeah.
Do you mean online?
No, it's different. It's, yeah, the Hungarian is kind of, you can take the cosine distance between each token of the input and the output, and then you try with the Hungarian algorithm just tries to find the least the least expensive alignment where you get the least mistakes. So it's kind of matching each token and tries to, of course they work because the word order and everything is different. So Hungarian really just goes after the similarity score and tries to make it as cheap as possible to match the tokens. And I think if you do that with our sentence alignment model, actually it should be quite good, I'd expect. So I'm happy to see if you get any results on that. Yeah.
Okay. I'll update you if I get a good result.
So the idea is to transfer annotation from one language to another by using the cosine similarity of token in one language and then match it to the other language token, right?
I think that's the idea, yeah.
And that's at the token level or the sentence level?
Token level.
Token level.
Token level, yeah. Okay. Yeah.
I think the only logical problem that might occur is that the number of tokens in Tibetan and in English could be quite different because the tokenizer is more efficient on English. So it will, maybe we have only 4 tokens on English, but we have 12 tokens on the Tibetan side. So that is something we have to. I don't know if the Hungarian algorithm is the best in that case because it's like unequally distributed. But there might be a way to solve that. So we have to check. Yeah.
And so by tokens, does that mean because are we talking about like sentence speeds or again like real words? Sentence speeds. Okay. Good.
Yeah, I was thinking about like creating like n-grams of like tokens and pulling their embeddings and trying to match them with a word, a token, kind of, so that we can kind of like, if it's like tashi, where it's like ta is a token.
That's actually.
Yes.
Yes, I think probably like algorithmically. The solution would be to combine your n-grams with the Hungarian algorithm, and then you probably end up with a lot of. I think the search path could be quite big because you can have so many different n-gram combinations and so on. So probably the model has to go through a lot, but maybe it's doable. So I think maybe the combination of n-grams that you suppose and then the Hungarian algorithms to get like a total sum of the alignment quality for the whole sentence. That sounds like a great approach.
Yeah. Thank you for your time, Sebastian. It's lunchtime for us.
Okay, no problem. It's also breakfast time for me, so.
Yeah.
Breakfast, okay, yeah. Okay, have a nice day.
Have a nice day.
Yes, thank you all.
Sebastian, one idea that we were proposing is that if we can do this kind of meeting every month or like at a regular interval, would that work for you? Because we will accumulate all the questions.
Yeah, sure. Good idea. Yeah, we can do it regularly.
Yeah, thank you.
Okay. Enjoy your lunch. Yeah.
Thank you.
Thank you.
Bye.
Bye.